All right, so the coordinate plane, I call it the coordinate plane plus because it's a little bit more than just the basic coordinate plane that we already did. All right, so as we know, the coordinate plane is formed by a horizontal number line and a vertical number line, right? Positives getting more to the right horizontally or up vertically. Negatives going more to the left horizontally or down vertically. Right? So that's what it looks like. You can sketch one in your notes, but we've already taken these notes already, so you don't necessarily have to redo it unless you would like to. Okay, the horizontal number line is called the x-axis. The vertical up and down number line is called the y-axis. And we separate. We use quadrants to name where points are located. So quadrant 1 consists of only positive numbers, right? If we went in a positive direction horizontally and a positive direction vertically, we'd end up in quadrant 1. And then the quadrants go counterclockwise. So 1, 2, 3, and 4. And we use Roman numerals to name the quadrants. Okay? So if you're asked where a point is located, you name the quadrant in which it's located. Yep, that's 4. The point where the two number lines intersect is at 0, 0, and we call that the origin. Okay, 0, 0, the intersection point is called the origin on the coordinate plane. Remember, an ordered pair, which is in parentheses, and it gives us an x coordinate and a y coordinate. It plots a point on the coordinate plane. The x coordinate moves left to right along the horizontal number line. And the y coordinate moves up and down after we've moved our x. So x comes first, right? In our ordered pair. X comes first. So we start at the origin. We move whichever way we need to move horizontally. Once we get there, we move whichever way we need to move vertically. Where we stop is where the point goes. Okay, let's practice. We're going to plot point A at 4, -2. All right, so the 4 represents how we're moving, horizontally, x. So we start at the origin, okay, and we move 4 in a positive direction because it's a positive 4. Once we've moved horizontally, then we look at our y coordinate. That tells us where we're moving vertically. So from that 4, we're moving down 1, 2. Okay, once we do those movements, that's where our point is, right here. And we can label that point A. Remember this? Point B is at -3, -3. So let's start at the origin. And we're going to go -3 because we're going to move to the left because it says -3 for x. And from there, we'll go down 1, 2, 3 for y because it's a -3 also for y. Plot our point. And we label it B. Let's do another one. What about point C? Can you label this in your coordinate plane? Plot and label. Starting at the origin, 1, 2, 3 in a positive direction. And then down 3, 1, 2, 3 because it's a -3. So point C would be right down here. In which quadrant is point C?
4.
Good. Quadrant 4. Perfect. All right, let's see if there's one more. I don't know if there is or not. All right, let's do point D, then we'll stop. And we'll stop with this. Okay, D is at negative 3, 3. So starting at the origin, we're going left, 1, 2, 3. And then up 3, 1, 2, 3. So point D would be right here. Good. In quadrant 2. Perfect. All right. Good. So for 0, negative 3.5, we don't move horizontally, and we just move down, and that point is between negative 3 and negative 4, right? How would we describe the location of this point? What would you say, Sam?
On the border, 4.
Good. Could you even be more specific on the
Y-axis.
Yes, on the Y axis. Good, because it is in between the quadrants 3 and 4, and it's right on the Y axis. Okay, we're going to start talking about reflecting a point across the an axis. Okay, remember the axis are the horizontal, the axes is the plural, and vertical number lines. Let's look at this point 4, 3. If we start with this point, we're given this point 4, 3. And we're asked to reflect it across the x-axis. All right, notice, let me do this kind of in red so we can see it. Like a mirror, if we kind of folded our coordinate plane along the x-axis, this point would be reflected. So think about that 4, 3. If it was like a blob of paint, we folded it in half and unfolded it. That is the reflection of that point, is as if it was getting folded across or mirrored on the other side of the x-axis. What do you notice about the coordinates of the point when we reflect across the x-axis? Mia?
It's the same spot for the y.
Yep.
But then the x, it's just going into the negatives and then the positives. So it's one staying the same and then one's changing.
Very good.
Positive.
Very good. The x value stayed the same for both, right? But we took the opposite of the y value. So in the reflection, it was still 4 for our x. But instead of positive 3, now it changed to the opposite, a negative 3, to reflect it across the axis. So here's our little rule of thumb. I don't recommend trying to memorize this. I recommend actually plotting the reflection and looking at the change. But here's what happens. To reflect a point in the x-axis, you keep the x coordinate the same, right? So 4 stayed the same in our reflected point. And then we took the opposite of the y coordinate. So instead of 3, we had negative 3. Its opposite has the opposite sign. Okay, and it reflects across that x-axis from quadrant 1, in this case, into quadrant 4. This is slightly different because where are we supposed to reflect this point? Liam? The y-axis. The y-axis. So the y-axis is right here. If you were going to reflect that point across the y-axis, where would the new point be? Tate, you want to go point on the board? Reflect it across the y-axis. So think about folding it in half. Perfect, right there. Perfect. Okay, we folded it in half. What do you notice about the coordinates? What happened here? Hudson?
The y coordinate changed into a positive number.
Which one changed to a positive?
The y.
The x, good, the first one. So we took the opposite of the x, but the y coordinate stayed the same. 1 stayed the same both times. Modibo, question. So our rule of thumb, although I think it's easier to do it than to try to remember the rule, is to reflect across the y-axis. First, find the y-axis. Your y coordinate is going to stay the same. 1 stayed 1. But we took the opposite of the x. So from negative 3, when we reflected, it became positive 3. First, we find the point. Oh, hold on. First, we find the point, negative 2, 4, which is right there. Good. Okay, now we need to reflect it. I'm going to write the coordinates in the x-axis. So find our x-axis, which is here. So we need to reflect it. We're folding in half on the x-axis. Fold in half. Good.
Other side.
Okay, notice the coordinates of the new point. The x stayed the same, but we took the opposite of the y. All right. Let's plot and label -3, -1. Okay, then remember we're doing the y-axis, so we're basically folding along the y-axis. Where would our new point end up? Perfect. Very good. Awesome. Good. What are the with a hand? What are the coordinates of this new point, Dylan?
3, -1.
Perfect. 3, -1. So we took the opposite of the x, but the y stayed the same when we reflected it in the y-axis. To reflect a point in both axes, so in the x and the y. Make it 2 steps. So first reflect it in the x, then reflect it in the y, or first in the y and then in the x, but don't try to do it all at once. Okay, let's do this one together. It says reflect 2, 1 in the x-axis and then the y-axis. So here's our first point. Let's thought 2, 1. Okay, that's where we're starting. First, we're going to reflect it in the x-axis. So we're going to go fold it in half along the x-axis and reflect it across that axis. Give me the coordinates of my new point. Liam?
2, -1.
Perfect. 2, -1. So my first step is to move it down here. Okay, once I get that point, that's the only point I'm going to use. So I've reflected it in the x. And then, second, I will reflect it in the y. Okay? Hudson, what will my new point be when I reflect this point in the y-axis?
-2, -1.
Perfect. -2, -1. So this is my final point. Reflected in first the x-axis and then the y-axis. What do you notice about the coordinates of this new point as compared to our original point? Liam?
Each of them had a 2 and a 1, but just negatives.
Yeah, they're both what?
Whole number.
Opposites, right? Both coordinates, when we reflect it in both axes, you just take the opposite of both. 2 becomes -2. 1 becomes -1. Point going to be on this graph. Where's -1, 2? Good. -1, 2 starts here. Okay, now, do you want to do it all at once or do you want to do 2 steps? 2 steps. Okay, let's reflect it in the x-axis. So where would our next point be? Perfect. Down here. Okay, I'm going to erase those 2 because now we're going to use our new point and reflect it in the y-axis. Where's that final point? Perfect. Thank you. Okay, with a hand, what are the coordinates of this final point? Miles, what are the coordinates of this final point?
+2, -1.
Perfect. You guys, what do you notice about the new point compared with the original point? We just took the opposite of each of the original points, right? -1 became +1. 2 became -2. Okay. Okay, the last little bit of this is about graphs and using, when we're given a graph, how we can see things explained with a graph. Okay, so graphs using ordered pairs can show trends in data. Read the labels on the axes. So in a graph, your x-axis will be labeled with something, whatever it represents, and your y-axis will be labeled with something that can help you see what's being represented in the data. For example, here is a graph representing hourly temperatures after midnight. Okay, so down here, this is showing us, this is 1 hour after midnight, 2 hours after midnight, 3 hours, 4 hours, etc. Okay? And then over on the left side on our y-axis, that's showing us how warm or cool it was that many hours after midnight. What can you say about this data? What's something with a hand? With a hand. What can you say about this data? Tell me something that's happening. Okay. We're at quadrant 1. It goes into quadrant 4. True. What else? Liam?
The temperature goes down.
Good. The temperature goes down until when?
Until
Yeah.
5.6.
Until 6 hours after midnight, right? It is decreasing until 6 o'clock in the morning. And then what happens?
And it goes up.
Then it starts to rise again, probably because what happened? The sun came up. Good. The hand. What else can you determine from this graph? What kind of a climate do you think this was taken in?
Desert.
With a hand. Roger, what kind of a climate?
Probably a cold one.
Why?
Because it's always, it's getting pretty cold during the night.
Right. The temperature in degrees Fahrenheit is between -5 and 7, so that's cold. So you can, from this graph, we can determine it's getting colder after midnight till 6 o'clock, and then it starts warming up, but it's still a pretty cold place in general because the temperature never gets that warm. Good. Let's look at this example. This says, this table shows the elevation of a submarine from each hour between noon and 5 p.m. So this is kind of a similar idea as the same graph, but they haven't given us a graph in this one. What do you think you're going to have to do? Make the graph.
Big idea.
So it says display the data in a line graph. Each of these, you guys, becomes an ordered pair. Right? This is an X, this is a Y. So this is an ordered pair, 0, -4.5. Hudson, will you show me where that would be on this graph? Thank you. If we plotted this point, close, down. It's going to go down. Yes, good, because we're going 0 horizontally and then down. So we'd have a point right here. Good. Who can show me where the next point would be? Kennedy. Show me where 1, -3 would be. Perfect. 1, -3. Dylan, show me where 2, -2.5 would be. Yeah, perfect. 2, -2.5. Modiba, where's the next one? No, which way should you go first? Yes. Yes. All right. Let's see. Will, show me the next one. And then, Owen, you can show me the last one. Both of you go up there. I'll put them both up at the same time because you won't be right on top of each other. Owen and Will. Yes. Okay, 4, -3.5. So this one went back down again. And then Owen's is at, go the other direction, +5. Good. +5, -4. All right, thank you. Have a seat. Let's look at this graph. What's happening with these data points? This is saying that X is representing hours after noon. And Y is representing the elevation of the submarine. What does 0 represent? Yes, sea level. So this is the water. This is the submarine. What's the submarine doing? What could you say, Sam?
We're just going up we're just going up. First
Yes.
up and then it goes back down. And it's really slow.
It's really slow. That's true. You're right. It's taking a long time. Good. So we can see the submarine rises and then it falls. We can see that it changes elevation over time. Okay? So that's just sort of what the graph helps us see is the movement of that submarine.